we have been asked to prove that the number 3n squared plus n plus 14 is even for all n in the integers. This symbol here, the upside down A, means for all. We need to show that for every value of n that is an integer, this is true. We're given a hint here. The hint is to consider the case when n is even and n is odd. So those are going to be the two cases we're going to consider. So we're going to start by splitting that up. So the value of n is either even or odd. That covers all possible options for an integer. So case 1, n is even. When n is even, that means we can write n as 2k for some value of k that is an integer. Now let's plug that into here. That means we have 3 times, 2k squared plus 2k plus 14, which is going to expand to, this is 4k squared, so multiplied by 3 is 12k squared, plus 2k plus 14, which we can factorize 2 out of to get 6k squared plus k plus 7. But since k is an integer, this is an integer, and so the whole thing is even. Since k is an integer, 6k squared plus k plus 7 is an integer, and so this is even. It is a multiple of 2. So when n is even, we know now that the result is going to be even. Now let's consider the second case, case 2, which is when n is odd. We're going to do much the same thing. Let n be, in this case, 2k plus 1. Again, where k is an integer. Substituting in for n as 2k plus 1, we get this, which expands to, again, we're going to get 12k squared. When we expand this, we're going to get 2k plus 2k, which is 4k. So then we're going to get plus 12k. And then plus 1, which multiplied by 3 is plus 3. Plus 2k plus 1 plus 14, which is 12k squared plus 14k plus 18. And similarly, we can factorize out that 2 to get 6k squared plus 7k plus 9, which once again is even. For the same reason as we said in case 1. It is even for both cases, which means that 3n squared plus n plus 14 is even for all integers.